Okay, Assalamualaikum and good morning. Are you ready?
Waalaikumsalam.
Okay. So, as usual, lah, please on your camera. And today we will continue our calculation on determination azimuth from solar observation. Okay, last 2 week we stopped at computation azimuth. Okay, inshallah, today we try to complete our calculation until the final answer. Okay, before that, I want to recap again about our last 2 week calculation that is from polar distance until computation azimuth before we complete our calculation. Okay. Okay, before this, you stop at observation azimuth. I think I forget something to tell you about the observation azimuth. It's okay. I will recap again, and then we proceed our calculation. Okay, so eh, sorry. Okay, okay. Last we calculate at computation azimuth, and then before we do the computation azimuth, we need to have the value of polar distance. Okay, how to determine the polar distance? You need first with declination, and then you get the polar distance. Okay, after that we will put the value for latitude and adjusted latitude at the space given, the row given. Okay, so why we need these three parameter to calculate computation azimuth. So I will show you. Okay, okay, this is observer position, kedudukan observer. Okay, bukan seperti not like NCP and SCP. Okay, this is the whole picture. Okay, the whole picture from your observation. Okay, for example, you stand at you do a solar observation at academic height. Okay, this is you. Okay, the center of the celestial sphere is you, observer position. And then this is uh, sun, okay, where this is north and south. Okay, above the observer head, we have zenith, nadi. Okay, zenith and nadi. Okay, so recap again about in lecture 1B. There is astronomical coordinate system. You have topocentric coordinate system and geocentric coordinate system. Okay, this picture is show the topocentric coordinate system. Okay, but if we combine topocentric and geocentric based on mathematical rules, okay, we also have on your celestial sphere, we will have NCP, SCP, and celestial equator. Okay, so I will put here NCP and SCP. We combine the topocentric coordinate system and geocentric coordinate system make as one origin. Okay, jadikan sebagai satu origin. Okay, if refer to the definition of topocentric and geocentric, they have different origin. Topocentric, the origin for topocentric is from observer position, observer location, and the origin for celestial sphere for geocentric is the center of the earth. Now we combine the origin, make as one, okay, one origin, which we apply the mathematical rules that sebelum ni saya dah tunjukkan sudut sudut bersamaan tu kan, okay, kita jadikan satu, and then now I put insert. Okay, So I put NCP and SCP. How we want to locate NCP and SCP at celestial sphere. Okay, remember again my lecture before is about latitude of observation. Okay, latitude of observer will be equal to altitude of NCP. Okay, now we see our latitude. Okay, kita tengok latitude kita berapa, kita berada pada kedudukan berapa. Okay, this is latitude of station. Okay, latitude of station is mean latitude of observation lah. Okay, so we get it. Station Azimuth. Okay. Okay, this is our latitude of observer ataupun latitude station. Okay, 6 degree 26 49.9 for north. So this means latitude of observation is equal to altitude of NCP. Okay, maksudnya ketinggian NCP tu sendiri. Okay, kita letakkan, we put our NCP and SCP. Okay, again my drawing is not follow the scale. So I just put, but it makes sense or logic where is the NCP and SCP. Okay, tak ikut scale tapi based on logic lah, janganlah tidak logik langsung. Okay, so this is 6 degree. Okay, this is NCP and SCP. Yeah, NCP, SCP. Where the latitude of observation is equal to altitude of NCP. This is altitude of NCP. Yeah, from here, from horizon to the NCP. Okay, this is altitude of NCP. It means the same as nilai latitude here. Okay, is equal to observation latitude of observer. Okay, after we create NCP and SCP, we can create celestial equator. Where is it? Where the celestial equator is 90 degree from NCP and SCP. Again, nak tidak ikut sikit lah. Allahu Akbar, sorry. Okay, saya agak-agak je. Okay. So after we have NCP and SCP, kita akan ada celestial equator. This is celestial equator. Okay. Okay, this is sun, matahari. Okay, you have already observed the solar observation, and then recap again about we go to lecture 1D. That is astronomical triangles. Okay, sebelum tu saya tunjuk sikit the slide for astronomical triangles. Recap again. So our solar observation, we relate to all our study, all the lecture note in our syllabus is relate to solar observation. So we go back to our astronomical triangles. Okay. Astronomical triangles. So, refer balik what is astronomical triangles. Okay. This one. Astronomical triangle is to solve in connection with determination of azimuth. Where astronomical triangles, dia ada parameter dia. Okay, this is parameter side elements and angle elements. Ingat balik astronomical triangles. Recap again what we learn in astronomical triangles. And then, so from astronomical triangles, we can calculate the azimuth for solar observation. Okay, so in order to determine the azimuth, solar azimuth by solar observation. Okay, in order to calculate by azimuth by solar observation, we need four data. Okay, we need four data. There are altitude, declination, latitude, and azimuth. Tak ada tak? We already have these four parameter, which altitude we get from vertical circle. Okay, altitude we get from vertical circle. Okay, and declination. Okay, declination is determined from published tables. That is the almanac. That is that one. This one we calculate last 2 week to get the polar distance and latitude. Okay. Latitude is the place of the place is determined by spread observation. Latitude of station. Okay. And then lastly is azimuth. Okay. Angle between observer meridian plane and altitude plane. Okay. Refer again. What is function of astronomical triangles? To solve in connection with determination of azimuth. Okay. If we can see here, azimuth measure clockwise from north point and it's occur at 2 point at 2 side which are at east side and west side. East side is mean the celestial body is rising and west side it happen when the celestial body is setting, goes down to to have a setting position, that is sunset, when it's become a sunset. Okay, tengok kat sini dia ada dua kaedah. Okay, when the celestial body at east, how we want to calculate the azimuth. When we the celestial body at west, how we need to calculate the azimuth. Okay, ni saya copy yang ni ingatlah. Okay. Ada delete saya lupa, I forgot to inform you last week, I think. Okay. Presenting, I back to our observation. Uh, okay, as I mentioned ni tadi, okay, we need 4 data. There is altitude, declination, and then third is latitude. Okay, altitude. Okay, declination, latitude, and azimuth. Okay, all these parameter we already calculate. We already determine previous from the previous lecture. Okay, altitude we get from vertical angles. Okay, yeah, this one vertical angles. Then you mean the vertical angles. Okay, you get mean altitude, and then you do the correction for refraction and parallax. Then we get adjusted altitude. So after you get the adjusted altitude, so what if you get the result for adjusted altitude? You put on the row of adjusted altitude, and then latitude of observation we already have at stage 2. Okay, this is stage 2. The calculation from stage 2, we get the latitude of station, and we also get the altitude, adjusted altitude. I put here, adjusted altitude. So adjusted altitude. Okay, this is adjusted altitude, and then what declination. So you also calculate the declination, which the declination we want to get the polar distance. Control C. And then you also have the azimuth. Azimuth is equal to bearing, but azimuth is more to we refer to true north. Okay, so you have azimuth. Where is azimuth? Observation azimuth we get from horizontal angle of sun. This one. Okay, horizontal angle for the sun, mean to sun. Okay, so computation azimuth, computation observation azimuth we get from mean to sun. Okay, okay. Okay, then we can locate our position of celestial body based on this parameter. Okay, so observation azimuth is 81 degree 27.5 minutes. Okay, what is azimuth? The angular distance ataupun the angle that we the angle from north measured clockwise until to the celestial body. Okay, first I will draw a celestial altitude circles. This is altitude circles. Okay, bulatan altitude circles. Okay, then then we locate the azimuth. Okay, starting from north, here north. Okay, measured clockwise until to the vertical circle. That is altitude circle. So sampailah sini. Okay, this is altitude. Altitude. I'm so sorry. Azimuth. Okay, this is azimuth. Okay, here azimuth. Okay, so altitude we can refer from adjusted altitude. That is 90 degree 52 minutes 27 second. Okay, warna apa pula? Biru. Okay, so adjusted altitude ataupun kita katakan altitude sahaja. Okay, from the horizon, angular distance from the horizon to the celestial body. Okay, altitude is angular distance from the horizon to the celestial body along the altitude circle. Okay, okay, this is altitude. Altitude. Saya highlight again. Okay, this is altitude. And then declination. Okay, declination, we start with the declination circle. So, declination circle is the circle, a great circle, start from NCP to SCP and back to NCP, but must cross to the celestial body. Okay, the circle that run from NCP to SCP and back again to NCP that must cross to the celestial body. So this is altitude circle. Altitude, declination circle. I'm so sorry again. Okay, this is declination circle. Okay, this is declination circle. Okay, so what is declination? Declination is angular distance starting from celestial equator. So celestial equator is the purple one. Okay, from the celestial equator. So starting from celestial equator, saya guna warna ni. Okay, start from celestial equator. The intersection between declination circles and the intersection between declination circle and celestial equator. Yes, starting from the celestial equator along the declination circles until to celestial body. Okay, we start here. This one until this to the celestial body. Okay, this is declination. Okay, do you understand? Any question? No? Yang lain? Faham
Faham, madam?
Okay.
Yeah, madam.
Okay, good. So from fourth parameter, okay, adjusted altitude, polar distance, and latitude and azimuth. Okay, we get the astronomical triangles. Okay, which one astronomical triangles? Mana the astronomical triangles? Okay, this is astronomical triangle. Okay, ni astronomical triangles. Okay, so this is astronomical triangles. Okay, from astronomical triangles, we got polar distance. So what is this? The parameter of astronomical triangles. Polar distance, zenith to NCP. Co-latitude, zenith to the sun.
Minus distance.
Zenith distance. Okay, the angle at zenith. Zenith angles, NCP.
Our angle.
Our angles and the parallactic angles. Okay. So the purpose ataupun the reason we do the solar observation is we want to get the azimuth, the true azimuth. That means the true azimuth for your reference object. It mean that angle starting from true north to the your reference object, to your target, okay, in your traversing line. Okay, so you want to get azimuth, it mean we need to refer again, okay, refer again to our astronomical triangles uh topic. Okay, azimuth is angles between observer meridian plane and altitude plane. Okay, because of sun is rising and setting, we have two side of sun, which is when sun at the east side and when sun is the west side. And we want to calculate azimuth, it will relate to the zenith angles. So we have these four parameter, and four parameter we will use on the astronomical triangle, which the formula for astronomical triangles to determine the zenith angles is what is it? Cos A. The formula on your form, okay, above below the details, observer details. Okay, cos azimuth will equal to cos polar distance minus with sine altitude multiply with sine latitude and divide by cos altitude times with cos latitude. That's why we have our latitude, adjusted altitude, dan polar distance. Okay. From this data, you will insert to your formula. Okay, computation azimuth. You will get the value of A. So this is the value of A. Okay, but the this A is mean this cos azimuth. The A is mean zenith angle. The A is mean zenith angles. Okay, so but so as we have two side of celestial body, east and west, kita kena tengok refer again kita punya time observation when we do the observation. In the morning or at the evening. Okay. So kalau in morning, dia adalah dalam keadaan the position of the sun is rising. Kalau evening, the position of the sun is setting or goes down to set. Okay. We have sun set. So bila when it's rising, the celestial body will rise at east and set at the west. So it become the two different position, east and west side. Okay, again. Zenith angles, to calculate zenith angles, it have two position, where is east and west. East and west. Okay, as you know, the motion of the earth make the celestial body looks rising at east and setting at the west. So it is rising, it is setting. Okay, terbit dan terbenam. Okay, rising usually occur when AM. Okay, in the morning. This is PM at the evening. Okay, when your time observation is your time observation at a morning. Okay, when you calculate the value of A, so when you calculate the value of A, that means zenith angle here. Okay, is equal to azimuth computation. Okay, is equal to azimuth. That means the value that you get from A, the result or the answer from the calculation from the formula. Okay, you have an value of A. If you do in the morning, you just put at the row of observation azimuth. But if you do at evening, okay, time it's setting, okay, at the west, it means azimuth is equal to 360 degree minus with 360 degree minus with zenith angles. This one. Okay. So this zenith angle is mean from computation azimuth from the formula. Okay. A tadi ni. Okay, faham? Boleh? Any question?
Tak ada.
Madam.
Boleh.
Tak ada Okay, again, I repeat, if your observation at the morning, so after you calculate the cos azimuth, cos A, so that means the value of A, the answer of A, you just put dekat computation azimuth. But when you do at evening, petang, Okay, please don't put this value. Maksudnya your calculation is not finished yet. Okay, maksudnya tak settle lagi your calculation. After you get the value of A, ni observation petang ya. Okay, so if you get the answer for A, you need to minus with 360 degree. After you minus with 360 degree, okay, after you minus with 60 degree, barulah you write your answer at the computation Azimuth. Boleh nah? Okay?
Boleh,
Okay.
madam.
Okay, good. Okay. So this our last week punya calculation kan. Okay, so I forgot to tell you about the east side and west side. So this is as you can see the observation at the morning. So you just use the value of 86, 27, 40.7 seconds and write down on the computation azimuth. Okay. Okay, this is computation azimuth. Okay. So after that, okay, computation azimuth. Yes, I want to show that what is the difference computation azimuth with computation azimuth dengan azimuth observation azimuth. Okay. No. Cancel. Last. Different from A with box A. Okay, so this is computation azimuth. This is observation azimuth. Okay, first your observation azimuth is you're observing the sun based on your assumed bearing. Okay, from the compass. So you assume from station 1 to station 2. Okay, from station 1 from station 2 to station 1. Okay, you assume as 15 degree. Okay, 50 degree. Then you observe the sun, you get the mean of the sun azimuth is 81, 28, 27.5. Okay, this is by your compass. Okay, this is academic height Okay, tak boleh. Ya, saya buat north dulu. Okay, this is north. Okay, and then you observe academic academic height kan. Okay, AKA and scan. So you observe A for example. Okay, so you observe A, you get the value, you observe A at 50 degree. This one. Station 2 to station 1. Example lah. Okay, station 1, so you observe 50 degree, 00 minute and 00 second. And then you observe the solar, sun, okay. You observe sun, you get 81. Okay, you get the value of 81.28. 81 degree, 28 minutes, and 27.5. 27.5 second. Okay, this is the azimuth for this is your observation value from your station to the sun using the assumed bearing or compass bearing. Okay, so we need to prove our datum. For example, for cadastral survey, so we need to prove our datum station 2, station 1. Okay, this one to prove station 2 to station 1. Okay, using the true north. Okay, based on the true north. Okay, this one is you assume or by PC. This example PC or PA. from assume bearing from assume ataupun from the prismatic compass. Okay, and then you need to prove your datum, okay, based on true north. Okay, kita nak dapatkan nilai kita punya station 2 ke 1. So you get from your assume, okay, so this means your north is based on your assume ataupun prismatic compass lah. So magnetic, kalau for example kita gunakan kompas lah, okay, we observe we start our datum ataupun we start our traversing by using uh, magnetic compass, okay, prismatic compass from station 2 to station 1, 50 degree, okay. So automatically this is magnetic north. Okay, so after you do a solar observation and then you get the data and then you process the data and then you do a solar you do the astronomical triangles calculation and you get the value of azimuth. Okay, the value of azimuth, that is azimuth computation azimuth. You get the computation azimuth. Okay, you get the computation azimuth is mean from the true north. Nilai that daripada arah utara benar, because kita observe matahari. So at the true north you get the 8627. Okay, the same sun, the same location and the same position, semua sama lah, tempat yang sama juga. So you get the 8627. 8627 14.7 second. Okay, so the true value is 86, but you get the 81. So we will have the difference here. Okay, and then we will correct our traverse, okay, our traverse line with this difference. Okay, kita akan buat pembetulan. Okay, kita akan buat pembetulan station 2 to station 1 based on this difference. Okay, kita akan betulkan balik kita punya traversing. Okay, nilai dia berapa. So how we want to know the difference? Okay, start your calculator. Okay, pegang kamu punya calculator ni. Lepas ni kita akan just masukkan kita insert our data dalam ni and then continue guna calculator sampai dah the final bearing. Okay? Dapat tak? Okay. So the difference here that provide the formula. Difference is equal computation minus observation. So we take the value of computation 86 degree 27 14.47 second minus with 81.28 27.5. Okay, please turn on your camera, please. Okay, so do a calculation. So after minus, what the answer for the difference? 47.2 second. Okay, this is positive difference. Okay, if you get the negative, you should put the negative here. Okay, kalau dapat positif is okay, just letak 4. Okay, if you get negative, letak negatif dekat sini. So in your calculator ni, in this calculator, you just use answer operation. Okay, no need to apa kita panggil ni, AC ni kita tak perlu kosongkan dia. Okay, just continue. So you get 4 degree, 58 minute, 47.2 second. And then we go to true RO, which we need to plus with mean observation RO. Mean observation RO adalah the value that we observe our RO. This one, 50 degree. Okay, we do two times observation, circle left and circle right, and then we get the mean to RO. Okay, so we get the mean to RO is 50.05 second. Okay, so to get the true RO, difference plus with mean observation RO. Maksudnya mean to RO. We plus with 50 degree. Okay. 0 minute, 5 second. Okay. No need to insert again. Just use answer plus 50 degree, 0 minute, 5 seconds. So you will get degree. Okay. Second, okay. So after we get the 2 RO, so abaikan ataupun ignore this level. Okay. So we go to convergence. Okay. So we want to calculate the grid bearing RO. So untuk dapatkan grid bearing RO, to get the value of grid bearing RO, the true RO must plus with convergence. But you need to confirm either plus or minus. How you want to look minus or plus? Okay, you get from this one. If our convergence at east, so it means you need to put negative 0 degree. Yeah, negative 0 degree. But at west, positive 0 degree. So kita akan based on this operation sahajalah. Okay, so 54, 58, 52.2 plus with 0 degree. Allahu Akbar. Answer plus with 0 degree, 2 minutes, 24.8 seconds. So you get, okay. So, okay, this is grid bearing RO. That means there is 55, 170. Yeah. Inilah yang kita dapat tu kan. 55, 1 minute 17 kan. Okay, 1 minute 70. Okay, this is the true value ataupun true azimuth for station 2 and station 1. So, solar observation ni, our reason to do a solar observation is one, correct the orientation of the traversing. Okay, dia betulkan balik orientation dia. Okay, dia bukan sama macam it's no same like cumulative C correction, cumulative correction kan. Okay, dia tak sama with the C correction. Okay, ini untuk betulkan kita punya kedudukan. So before this we based on magnetic compass ataupun we based on assumed bearing. So we correct our value from the solar observation. One of the method lah. Okay, ada juga method-method yang lain tak menggunakan solar. Okay, so one of the method to prove datum ataupun correct our datum is based on our solar observation. Okay, not finished yet. Okay, so this is for observation 1. Okay, then you need to calculate for observation 2. Okay, after you calculate the observation 2, okay, if you want to know your data is acceptable or not, you need to minus this grid bearing RO. Okay, grid bearing RO for observation 1 minus with dah penuh dah. Okay. So grid bearing RO for observation 2 must less than 10 second. Okay. Within this tolerance, barulah your solar observation has been accepted. Okay. More than 10 second, the tolerance the tolerance is depend on our instrument and our site location. Okay. So for me, for your observation, your practical, so must less than 10 second. More than 10 second, so we deduct your mark. Okay, makin sikit, makin sikit, makin sikit. Okay, boleh? Still tak habis lagi. Ada lagi, tak habis lagi. Okay, after you know that is acceptable, then you will, you need to calculate mean grid RO. Okay, kita nak dapatkan mean grid RO. The only one value for one observation. Okay, so macam mana nak dapatkan mean grid RO? Dah nama mean kan dekat sini atas ni, mean. So it's mean, it's mean. Okay, mean grid RO mean. Okay, bila kita kata mean, dia adalah purata, average. So we will we sum the grid bearing RO1 plus with dengan grid bearing RO2 divide by 2. Okay, good. Okay, get it? Berapa? 15 ke T? 15. 16? Oh, 16 minit. Okay, yang lain mesti tengah ngau. Mubim dah buat kan? Kamu tak buat lagi kan, betul tak? Dah buat belum? Yang lain? Belum. Okay, so this is the answer from Mubin. 50. Are you sure? 55 degrees, 60 minutes, 14.8 second. You already okay, it's okay. Okay. So now I want you to calculate. You complete for observation 2 and then get the answer and check whether it is a same like Mubin or not. Now, sekarang saya nak semua orang kira. Sekarang. Okay, calculate for observation 2. Ingat balik, this one is from last 2 week, tak lama pun. Okay, baru je 2 minggu lepas. Okay, calculate balik for declination, how to read the declination at declination tables, how to find the difference, how to get the declination at time observation, and after we get the declination at time observation, you need to calculate for polar distance and then computation azimuth and then so on. Okay, so please do it now. In 10 minutes, boleh? Dalam 10 minit, okay? Sikit je ni. Okay. Wait, I create a form for quiz. Okay, you may ask kalau tak tahu, boleh tanya. Bukan tanya jawapan, but tanya apa yang tak faham. GLS184 LP. Okay, Dan? Dah?
Sikit lagi, madam.
Right. Okay, you can go to the Google Classroom under topic solar observation. I already okay, go to the exercise observation. Saya tulis itu exercise observation 2 and then put your answer at the spreadsheet. I'm not given the name of spreadsheet ke. Exercise 2.
Madam,
Yes.
dia ada request access kat situ.
Huh? Why?
Kan Google Drive kan?
Ya, sekejap. Saya try tengok. Aduh. Access pula Sekejap saya buka.
Access denied.
Okay, tak apa. Saya buka access tu. GLS184 Google Classroom. Classroom 84. Exercise. Okay, cuba try again. Okay, try again.
Dah boleh, madam.
Dah boleh okay, so setiap orang letakkan nilai masing-masing. Okay, please jangan meniru. Jangan follow your friends, okay? Sebab kalau kamu tak ni, kamu tak akan belajar. Di mana salah kamu? Cepat, lagi 1 minit. One more minute. Do you need a take 5? Perlu ke rehat 5 minit? Takut dah nak calculate. Okay. So take 5. Tapi dalam take 5 tu jangan lupa lah isi benda ni. Okay. Take 5 sambil kira. Still request ke?
Tak boleh nak type, boleh tengok je.
What? Only saya dah set sebagai Sekejap, saya setting balik. Saya dah set sebagai oh ya, sorry. Okay, again. Saya dah buka setting dia dah. Cuba tengok.
Tak boleh juga Adam.
Tak boleh juga.
Ha.
Tak boleh. Kenapa tak boleh? Macam okay, share. Okay. Change. Okay, again. Cuba baca bismillah sikit. Bismillahirrahmanirrahim. And then, put your answer. After you read bismillah.
Okay, dah boleh lah.
That's why you tak baca bismillah tu.
Dah boleh lah.
Lain kali apa-apa kerja, baca bismillah dulu. Syaitan ganggu. Okay, boleh? Okay. Put down your answer and then we will check one by one. Tengok. Okay. So please don't copy your friends. Okay. Macam last week kan kita follow ayah pin kan. Lepas ayah pin tu salah, betul tak? Siapa tak ayah pin minggu lepas? Ya, Mubin ke? Okay itulah. Harap ayah pin tu dah insaf dah. Tapi rasanya ayah pin pun tadi dia buat awal-awal pun salah juga. Okay. Tak jawapan. Okay, Boleh ke saya close sekejap saya punya my Excel? Boleh ke? Ataupun kamu nak tengok dulu? Hello?
Saya nak tengok.
Nak tengok. Okey, okey. Sebab kalau tidak saya nak tunjuk jawapan kawan-kawan dekat depan ni. Saya nak tukar presentation, saya nak present our Google pula dah, our Excel, Google Excel, okay. Tapi kalau kamu dah nak tengok ini tak apa, it's okay. So saya kecilkan sikit, even pening sikit. Okay, sekejap lagi saya share kawan-kawan punya result pula. Apa nak letak? Okay, yang lain mana? Lapan satu equals to RO. Itu RO. Itu RO. Itu RO. 4. Okey. Ada Hana Fahda, Alia Husna, Adriana Aisyah, Muhaimin, Iqbal Syafiq, Faizuddin, Akil Zainul, Akil Hafiz, Atik, Syazwan, Jasmine, Ashanani, Adin, Anis Adin. So where are you?
Tengah kira lagi, madam.
Okay. Cuba on kamera kamu supaya saya nampak. Yang lain? If you have any question, you can ask. Saya jawab. Saya ulang balik. Saya boleh ulang balik apa yang kamu nak tanya. I will repeat again the calculation. So maybe in 2 weeks, next week ataupun another weeks, we will have our quiz. Okay? Only for solar observation. Okay? Tak ada yang lain. Just solar observation sahaja. Calculation. Within 1 hour, you need to complete the calculation starting from observation 1, starting from phase 1, you go to phase 2, phase 3, phase 4 and phase 5 until you get the final answer. Okay? Either next week ataupun another 2 weeks. Hmm. Ya, yang first tu ke? Okay, yang pertama sekali yang ini, yes. Refer to start mana?
Itu yang declination at kurangan tu 529.80 tu latin yang kena cari kat daftar mana?
Ya, betul.
Okey.
Kenapa?
Tanya je.
Oh, okay.
Thank
Sebab
you, madam.
dua kali soalan. So, macam confused bila tanya soalan yang sama. Okay? It's okay, boleh. Okay, so macam yang saya beritahu minggu lepas lah. Okay, start amanah setiap every year sometimes the difference the difference presentation dia adalah secara different. Sometimes it will give in degree minutes and for declination, and sometimes it give degree minute and second. Okay, nak guna mana-mana tak ada masalah. Sebab apa? Sebab it's still the same value. 5 degree 29.8 minutes we equal to 5 degree 29.48 second. Okay, sama je. Okay, so dah. Okay, Hasha Hanani, where is Hasha Hanani? Absent ke? Hasha Hanani?
Ada.
Okay, Akil Hafiz? Tak habis-habis lagi. Tengok kat depan komputer dari tadi lagi.
Belum lagi, madam.
Belum. Okay.
Hehehe.
Okay, Faizuddin, where is Faizuddin?
Ada, saya.
Kira tak?
Saya tengah buat lagi, madam.
Tengah buat, okay. Muhaimin, where are you? Muhaimin?
Saya ada.
Still?
Saya ada.
Tengah. Okay. Kamu tak buat, kamu tak nampak apa yang kamu tak faham dan kamu tak nampak apa yang salah. Again, jangan refer kepada ayah pin. I don't mean Mubin, tapi siapa-siapa je lah yang nak jadi ayah pin sekejap lagi. Okay? Yakin dengan diri sendiri, your answer is betul. Dah yang lain? Cepat, dah pukul 9:35 dah. Observation Azimuth, yes, mean to sun. Okay. Okay, Ashana ni, Jasmine, you already behind. Aki Hafiz. Hmm. Hmm? Okay. Saya rasa saya tahu lah soalan kamu apa. Hmm. 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 Actually not degree lah. That is hour. Hour, minute and second is different from angles. Okay. This one. Okay. Okay. Different equal to GT observation minus with time at declination kan. So in case you do the observation at everything apa 17 jam. Okay. Your observation at uh, 5:30 p.m. Okay. So 5:30 p.m. minus with 8 hour kamu dapat apa? 5:30 5 hours 30 minutes. Jadikan 24 hours. Okay. 70 30 minutes kan. Okay. So you minus with 8 hours. Okay. To get the Okay. Dapat apa? 9 setengah. Okay. 9 30 minutes. 9 30 minutes. 9 hour 30 minutes. So the value of 9 hours 30 minutes tu ambil pen warna kelabu lah senang. Yang coklat. Saya tak pernah guna coklat kan. Okay, 9:30 ni berada between 6 and 12. So if this 12, so 9:30 ada kat sini. Okay, so if you ni saya dah bagi contoh sebelum ni. Okay, so kalau nak if you want to calculate difference 9 GT observation 9 hour 30 minutes 00 second minus with nilai yang kamu refer iaitu 6 hours. Okay, at time observation tu kan dalam kurungan kan kamu letak 6 kat sini kan, so minus with 6 hours. Okay, and time with velocity yang itulah, the difference of velocity dekat situ. Okay, boleh?
Madam nak tanya.
Ya.
Kalau kom azimuth
Okay.
dapat untuk yang second observation.
Ayam macam mana?
Kom azimuth tu macam mana nak dapat untuk second observation?
Computation azimuth. Computation azimuth nak dapatkan untuk observation guna formula lah. Cos A equal to cos P minus sin altitude darab sin latitude divide by cos altitude times with cos latitude.
Ini untuk yang second observation ke?
Ya, untuk computation azimuth dia punya formula yang ini sahaja. Either first observation ataupun second observation ke, dia punya rumus ni memang yang ini. Untuk kita dapatkan nilai zenith angles kita. Once kita dah dapat zenith angles, kita akan dapat azimuth. Okay, refer to the celestial body position. At the east, kita akan ambil nilai zenith angles tu apabila the sun berada the position of the sun at the west, okay, 360 degree minus zenith angles tersebut. Okay, get it? Okay.
Thank you.
Okay, if you ask me why to get the azimuth at west side you need to 360 degree minus with zenith angles, please refer back to the topic 1D astronomical triangles. Dalam tu saya dah maklumkan dah kenapa. Okay, lain cepat. 9:41, lepas ni ada kelas tak? Okay, Hasha Hanani. Okay, Jasmine.
Sekejap, madam.
Okay, boleh tunggu tapi jangan ketinggalan sangat. Kawan-kawan dah ni dah ni.
Lepas ni ada kelas madam.
Lepas ni ada kelas.
Ah,
Okay. Hasha Hanani dengan Jasmine adakah rumit? Hasha Hanani dengan Jasmine adakah dia rumit?
Agaklah saya masih confused sebenarnya ni madam.
Jangan madam duduk kira kom azimuth.
Okay, it's okay.
Madam,
Ya.
boleh tengok tak yang formula yang mean grid bearing RO tu?
Mean grid bearing RO. Mean grid bearing
Bearing RO.
untuk solar observation lah. Mean grid ni, mean grid bearing RO.
Dia punya formula.
Dia formula adalah true RO just plus or minus with convergence, and you will get grid bearing RO.
Saya tak yang mean.
Mean ni mean. Okay plus tu bro. Grid bearing RO
Plus ke minus?
plus. Kita nak dapat purata. Kalau kiraan purata macam mana? Purata ataupun average macam mana? Kita total
Okay,
semua
faham.
and then kita
Total
divide
so
by
bagi number of ni.
yes.
Bilangan dia. Okay.
Yeah. That's why saya
Okay, thank
kata
you, madam.
yeah. Okay, that's why saya kata kadang-kadang tak adalah. Dia actually tak complicated. So dia macam contohnya saya bagi contoh lah, kita belajar mengenai star transit. Transit tu sendiri bermaksud perubahan, pertukaran. So we can know matahari bintang terbit dan terbenam. So dia akan ada dua perubahan je. Dia semakin meninggi ataupun dia semakin menurun. At the one point dia akan berubah daripada naik kepada turun. That is transit. Okay. Even kamu belajar dalam astronomy, but the term is still some of the term is still kita can relate with our life. Kita punya keadaan. Okay. Adalah macam yelah celestial sphere kan. Celestial sphere lain lah benda. Kita baru belajar. Tapi ada certain term tu adalah memang apa yang kita harian kita tu kita gunakan. Okay. Cuma kita apply pada konsep yang berbeza. Okay, saya pun dah pening ni. Banyak nilai lain-lain pula. It's okay kita ni. Okay, saya bagi sehingga 9:15 and then after that saya akan tutup access. Okay, I will close the access for this and we will sebab kita akan check balik. Yang ni siapa yang color-color ni? Akmal Hakim, kamu tak payah color-color. Saya color because of the reason I want to see the difference between the different answer between among your different answer di kalangan kamu ni. That's why saya color. No need to color. Okay. So saya akan tutup 9.50. After that kita minggu depan saya akan check balik. Saya akan tunjukkan siapa yang salah. Saya tutup sebab saya tak nak lah access kan. Okay, nak tunjuk siapa yang salah. So make sure kamu jawab sampai 9.50. You have 2 minutes left and then kawan-kawan yang dah siap menjawab tu boleh sign your attendance in your future. Okay. Sebut attendance in your future. Okay, sambil-sambil tu saya ambil attendance Akmal Hakim ada, Hanis Adin ada, Asha Hanani, Izzah Abidah.
Tak ya, madam.
Okay, Yasmin ada, Khairin Nabila.
Ada.
Okay, Syazwan.
Ada, madam.
Okay, Atik Karim.
Saya, madam.
Akil Hafiz ada, Akil Zainul ada, Faizuddin ada, Iqbal Syafiq.
Saya ada.
Okay, Mubin ada, Muhaimin ada, Nakyu? Nakyu?
Ada madam.
Okey. Rafiq Azai?
Ada.
Okey. Saiful Syahmi?
Ada madam.
Okey. Aisyah Ifah?
Ada madam.
Mana tengok sikit?
Ya.
Okey. Okey. Adriana?
Saya madam.
Okey. Alia Husna?
Saya.
Okey.
Saya madam.
Alia Nabila?
Saya madam.
Alia Zambi?
Saya madam.
Ana Fahda?
Saya madam.
Mana?
Saya.
Okey. Nurul Atika? Nurul Atika tidak hadir Nurul Atika? Nurul Syakira?
Saya madam.
Nurul Atika ada tak? Tak ada itulah. Google Meet. Ni, dalam ni. Google Meet. Wan Syakira? Okey. Wan Syakira?
Saya madam.
Ya. Wan Syakira? Wan Syakira 1. Wan Syakira 2. Wan Syakira 3. Wan Syakira 1. Tak dengar lagi? Okey. Okey, itu sahaja. Yang lain tolong isi. Okay, so ini just sembang je lah. Okay, so for the close, before we sembang santai. Okay, so before our close our topic, this solar observation, I hope you achieve our lesson outcome. So the objective or our lesson outcome for this topic, you should be able to practice procedure of azimuth declination by solar. Ini saya dah cover waktu LP. Okay, itu kamu tahu the way to collect data for ataupun the way to have a procedure of solar observation, and then you able to determine azimuth based on sun position. Okay. So kita tak habiskan lagi yang ini, tapi daripada topik yang saya ajar dah tamat. Cuma untuk tentukan betul ataupun tak your determine azimuth based on sun position ni, kita tengok balik pada minggu hadapan. Okay, kita tengok the result, everyone result, tengok sama ke, salah ke, betul ke, ayah pin ke ataupun mengikut arah yang benar. Okay. Okay, itu sahaja untuk topik kali ni. Okay. So, the end of our class, ya. Cuma just nak sembang-sembang sikit lah pasal final assessment. Okay tak final assessment kamu? Just sembang before saya close kita tutup kita punya kelas hari ni. Okay tak kamu punya final assessment?
Boleh lah. Okay madam.
Boleh madam.
Tak
Okey.
tiru kan? Tak tiru, tak sembang kan? Tak tiru, tak discuss kan? Lepas tu tak tiru dengan tak discuss, lepas tu mulut macam ni. Ya. Mulut pun tak nak buka, tak buka. Okay. Yang tu dari segi amanah tu sendiri pikul lah. Okay, harapnya daripada jawapan yang saya terima, dia akan melalui ni lah. Kan saya kata no plagiarism kan. Plagiarism tu maksudnya kamu copy and paste lah. So kita boleh tengok lah sama ada kamu copy atau paste. Kita akan boleh check balik lah. Okay. So just to ni lah, saya dah tengok dah sikit-sikit. Okay, saya just roughly go through hari-hari the first once kamu dah submit semua, saya go through sedikit by sedikit. Cuma itulah saya tengok ada yang macam meniru, ada yang macam saya tak kata meniru, saya tak tuduh. macam. Okay, ada juga yang jujur dia buat sendiri. Kita boleh detect tau siapa yang jujur buat sendiri, siapa yang faham, siapa yang tak faham meniru, siapa yang tak faham buat sendiri, siapa yang faham buat sendiri dan siapa yang faham meniru. Benda tu kita boleh kita boleh differentiate lah between 4 kelas ni. Okay, so Alhamdulillah ada je yang buat sendiri tanpa tengok buku, tengok memang dia struggle lah menjawab. And then cuma saya tertarik dua benda ni lah, dua student ni, Aisyah Ifah dengan Ana Fahda. Saya tertarik daripada tulisan diorang, cantik. Kalau kamu tengok tulisan yang lain pun cantik juga. Tapi seriously Aisyah Ifah ni tulisan dia memang satu-satu. Kalau nak marking pun sejuk je mata memandang. Yang lain pun sejuk juga. Cuma ada api-api sikit, panas sikit je kat situ. Okay, saya tak check lagi, cuma saya tengok roughly. Saya tengok student saya submit the correct document. Sebab before this ada je yang dia tersalah, dia jawab, kamu kan buat secara online, kamu save kamu punya jawapan dekat situ. Okay, dia pergi ambil yang dia jawab sebelum ni. Maksudnya dia buat KDES Astro, lepas tu dia pergi attach dekat saya KDES. Pernah jadi, that's why saya tengok lah. Bila dah tengok tu, saya tengok jugalah jawapan kamu kan. Dah tengok jawapan tu, saya suka tengok tulisan. So nice. Kalau F2F memang saya rajin juga tengok tulisan orang. Okay, itu just sembang-sembang belakang je lah. Tak ada kaitan pun dengan exam. Okay, so please before saya tutup saya punya Excel ni, tolong completekan lah. Okay, saya hanya tutup sampai pukul 10. Next kamu ada kelas kan. So lepas tutup ni kamu dah tak boleh isi dah lah. Sebab saya tak nak kamu tukar nilai. Sebab saya nak tengok siapa yang betul, siapa yang salah. Yang mana yang salah tu mungkin kita boleh